Hello everybody, day 2 of Exponentials, and I think this will be shorter than the ones yesterday. I hope so. Okay, solving, simple solving. Hopefully you can look at A here and say, okay, fine, 2 to what power is 32? Oh, I know my base is a 2 because computers are all based on binary and base is a 2, so, well, x should be equal to 5. Okay, fine. Hit pause and see if you can come up with the answers for the rest of these. Okay, I'm back. I didn't pause. Hopefully you did and you actually have the answers. 2 to what power is 256? Well, I'm just going to do this off of memory. I believe 16 squared is 256. So this is a good review of powers and power to power, exponent properties and all that. Now 16 is 2 to the 4th power because it's 4 times 4 and 2 squared times 2 squared, 2 to the 4th. So 2 to the 4th squared, power to a power rule, x should be equal to 8. It's just a way to think through that process. Okay, 3 to what power? 3 times 3 is 9, and 9 times 9 is 81. Therefore, it must be x equals 4. 4 to what power? Hey, this one looks a whole lot like that one right there. And so, 4 squared is 16, right? So that means 16 squared equals it, and 4 squared squared, and therefore x must be equal to 4. Okay, now we just thought through that process by reasoning through it. So what's the underlying principle at work here? If I rewrite each side as a power of the base on the left, well, okay, hopefully you can see that this is 2 to the 5th is equal to 32 is 2 to the 5th also. I really should put x here. That's the whole idea. Okay, hit pause. No, seriously, hit pause. Don't just like, fine, Mr. Roth is going to keep going in a second. Hit pause and just write the answers out for all these. Okay, we're back. You say, fine, 2 to the x equals 2 to the 8th, therefore, and really what we're saying is, using this method, then I could say, okay, fine. So in words, what are we doing here? One way of solving exponentials, and I don't need to know logarithms for it, if I can get both sides of an equation to be the same base, well, if the base is the same, well, then the powers must be the same, so x must equal 8. So fine. If bases are the same, I guess both sides of equals, then powers must be equal. Okay, simple as that. Anyway, this would be 3 to the x equals 4 to the 4th, right? I think that's what we said. And this is 2 squared to the x power equals, I'm going to do this a little bit different. We already said 4 to what power is to the 4th. And so you'll end up getting back to 2x, 4 times 4 is 16, yep, that's right. Wait, was x is 4 on this? Oh, yeah. Wait, what am I doing? I got to think about this one. 4 to the 4th. Oh, I have to make that 8. I got that to powers of 2, so I really need to do 2 to the 8th, right? So I'll get back to x equals 4 if I do it that way. I was trying to be clever, and that's what happens. Okay, what if the bases are not the same? Can you make the bases be the same here? And hopefully you say, oh yeah, I recognize 8. 8 is a power of 2 as well, so I can turn that 8 into 2 cubed. Now don't forget, I just turned the 8 into 2 cubed, so there's still the x there. And then I have 2 to the x minus 1. Oh wait, I'm going to add some more space here. I think it'll be helpful for the rest of these. There, now I got more room. Power to a power rule would say, 3 times x then would have to be equal to x minus 1. Oh, I can solve that problem. That's not that bad to solve. So 2x equals -1 and x equals -1/2. And that should be it. Okay, why don't you hit pause, try to work through the rest. Oh, before I forget, make a change to this one. Which ones we're going to make the change to? Actually, the second one and the fourth one. The homework for tonight has inequalities, so I wanted to introduce those. So I'm going to change this to be a less than or equal to here, and this one should be just plain old greater than. I actually changed it on the worksheet for next year's group, but we'll have to change it manually. Okay, now, will the inequality worry me? I don't know. Give it a shot. Pretend it doesn't. Try to get to the same base and try to work through these. And actually do it. Struggle with it a little bit if you need to. Hit pause, and I'll come back. Okay, I'm back. So I'll use blue. So hopefully everybody saw that 27 is 3 cubed. And then I'll have my x plus 3. I have my less than or equal to 3 to the 2x. Now, if I have a base of 3 on both sides, and don't forget, this is the same as 3 to the, remember I'm going to power to a power, I'm going to multiply 3 times x plus 3. That'd be x plus 3, right? No, wait, x plus 9. 3x plus 9 is less than or equal to 3 to the 2x. I have the same base on both sides. I think I want more space. I have the same base on both sides. Therefore, can I just say 3x plus 9 is less than or equal to 2x? Seems right. Equal to 2x. Solve that. I will get x, subtract that, less than or equal to -9. And should be right. You can plug numbers in. Try to plug in the -9 and see if it makes this true up here. By all means, check your work. Now, the next one, hey, that one's weird. What is the common base here that I can get to? Well, I know 8 squared is 64. So if I want to do this one, I want to get a power of 8 over here and a power of 8 over here. Well, this one's easy. 64 is 8 squared. And I'll just put the x plus 2 up there. What power of 8 will get me to 1/8? Well, I remember my power properties. That's 8 to the -1, the x power. Okay, power to a power. Let's go. Negative x equals, and then I'll have, I got to distribute, remember, power to a power, I got to remember to distribute the 2 into both those guys. So it'll be 2x plus 4. Subtract 2x from both sides. I'd have -3x equals 4, or x equals -4/3. And to save time, I'm not going to take your time to plug these back in, but it's not a bad idea to plug these back in and prove to yourself they actually work. You can use your calculator if you like. Okay, let's go to this one. Ooh, this one looks weird. There's a fraction on this side and there's a fraction on that side. What's going on? What do we recognize? 81, and it is helpful to remember your powers of 2s and 3s especially to work these problems out. 81 we just did a second ago is 9 times 9, so that must be 3 to the 4th. 16 likewise was 2 to the 4th. Huh, that's interesting. It seems like I can turn that side into 3 over 2 to the 4th. Prove to yourself that that actually works. 3 to the 4th over 2 to the 4th is 81 over 16. Okay. Now, if that's 2/3, should I keep it as 2/3? Well, I want to get to 3/2 according to this one. And what power of 2/3 would be 3/2? Well, raise that thing. The parentheses is kind of in the way. The whole 3/2 we want to raise to the I really need to put the -1 outside the parenthesis there. Now, 3 halves to the -1 power would be equal to the 2/3. Good enough. I'll put a red bracket around this. Now that, the red is equal to the 2/3. Then that is raised to the 4x. Now, okay, let's try to go through this process. If I distribute -1 to 4x, I get -4x. Oh wait, I had a greater than here, didn't I? That was supposed to be not equal, but greater than. So -4x is greater than 4. X is greater than -1. Okay, that's one option. Let's see what happens as an alternative if instead of that I take the 2/3. So I'm going to actually go work right down here, and I leave this as, oh wait, what happened? As 2/3, and to the 4x, I still have my greater than, and instead of 81/16 being 3 halves to the 4th, I say, let's make that 2/3 to the -4th. That's one way to do it. And then I would get 4x is greater than -4, x greater than -1. You can go either way. Okay, let's circle one. I believe this next problem is simply reviewed from yesterday. So, how much do you have in 10 years? 5,000 at 4% interest compounded daily. Remember your formula, A equals P times 1 plus R over N to the NT. Remember the divide by N converts the annual rate into a monthly. Wait, this is a daily rate in this case. And NT is the number of days you're compounding it over, so it's 5,000. 1 plus 0.04 divided by 365 days in a year. Hopefully everybody remember that. 365 times 10. And I actually have this worked out, I think, from last year. 7458.96. And hopefully I actually worked that out of me. I forgot to say pause. How long would you have to wait until you had 10,000? Oh, that's interesting. What would I do in this? I want the amount in the future, this amount right here, to be 10,000. I still started with 5,000. And 1 plus, what was it, 0.04 divided by 365. And okay, fine, I still got my 365 and t. What should I do to solve that? Well, I could divide both sides by 5,000. That's a good thing to do. I can do that. And notice I only get 2 on that side. So in the end, it didn't really matter that it was 10,000, 5,000. The only thing is the ratio. In this case, I'm doubling my money. So it's a ratio of 2. I'm doubling. What is 1 plus? Let me get my calculator out. I don't have it written down here. 1 plus, and hopefully you don't pause and work it. Don't just let me do all the work here. Divided by 365. 1.g. Now, this actually brings up a really good point. These are super, super sensitive to decimals. And remember the 3 sig fig rule? Doesn't work anymore on these things. You got to keep a lot of sig figs. When you're having exponents, I'll say 9/6. I kept a whole lot more than 3 sig figs because it's very sensitive. You don't want to even have to retype it in to the calculator if you're going to avoid. Do you know how to solve that? No. So we do not know how to solve for variables in the power. And we'll learn that in our next lesson when we learn logarithms. Okay, fine. Keep scrolling. An exponential, we're almost done here. An exponential equation that goes through these 2 points. That's interesting. What do you remember? Yeah, I remember y equals mx plus b. With given 2 points, I can solve for both my slope and my y-intercept. I remember that. But I want to go through an exponential. So what is the basic form for exponentials? A. Now, that's a B. And remember, we have our x minus h plus k. That same AHK form always keeps popping up. Now, how many unknowns do I have in this situation? I don't know an A, could be anything. I don't know the base, that could be anything. I don't know the H, that could be horizontal shift. And I don't know the K, 4. I have 4 unknowns. I am going to plug in these are XY points, so that's what's going to go in the Y and the X here. I cannot solve for all of these guys. With 2 points, I can write 2 different equations, and if you remember system of equation rules, you can only solve for 2 unknowns, not all 4. So we're going to call this to be the form of exponential, the simple form with an A and a B. I can't deal with H and K with only 2 points. Might have to have at least 4 to get all of them. Okay, so how do we work with this? Well, we could plug in points. Let's just plug in our X and Y and see what happens. Call this point 1 to get equation 1. Y is 3 equals A times B to the x power, which is 1. Okay, fine. Then, what color should I use for the other one? I'll use purple. This will be my point 2, which is going to give me my equation 2 over here. And so 8 is equal to A times my base to the 5th power. Now there's a couple ways to solve these. You could solve this top one for A. A is 3 divided by B, and then plug that in right here, and that would work. That's called, systems by substitution. There's kind of a clever way. If 3 equals A times B to the 1, and 8 equals A times B to the 5, in other words, this side equals that side, and those sides equals these sides, can't I divide and say, well, right, let me write the numbers down. This is equation 1, and this is equation 2, right? Can't I divide either equation 1 by equation 2, so that 3 divided by 8 equals the blue side divided by the purple side, or the other way actually works out nicer in this case. Equation 2 divided by equation 1. So I'm going to say equation 2 divided by equation 1. If I do that, on the left side, I get 8 over 3. Notice, when I'm dividing on my right sides, I'm going to have A divided by A, which is 1. B to the 5th divided by B to the 1 is simply B to the 4th. So, lo and behold, what do I get? B is equal to, the 4th root of 8/3. Now, what can I do with this? It's like I got my y equals mx plus b, and that's like my slope. So I plug it back into one of these equations. Which one's easier to work with? Well, that one looks nicer to me. So I'll substitute it back in to equation 1. And then I get 3 is equal to A times the 4th root of 8/3. So A is equal to 3 divided by the 4th root of 8/3. Now, I shouldn't leave it like that, but those are my A and B coefficients. You can get decimals if you want. That's trickier, I think, than most of the ones you'll have on your homework assignment, but that should get you through your assignment. So good luck with it, and what's good saying? Sawubona. That's the Zulu thing I said the other day. Remember all these things. Later.